Okay, good morning, everybody. I see a few of you out there, so I'm glad you could be here. I know 8 a.m. is kind of a pain, but I also thought if I had to sort of get myself at one end of the day or the other, maybe those of you who are working might be able to do this time. So I'm sorry if you can't, you're watching the video later, but I had limited options. Good morning, that one kid. Nice to see you this morning. So, we're in week 2, and the good news for your class is that I saw everybody in terms of activity. So that's unusual, and that's something that I think we can be encouraged about going forward. That everyone in the class was active in the first week. Everyone contributed to the discussion. Everyone turned in all the assignments, as far as I can tell. So that's a good start. So hopefully we can keep up whatever we need to do to keep our energy up over the course of this semester, or sort of grind through the lower points. That would be great if we can do that. Okay, so thanks also. A lot of you had to be patient in terms of getting virtual machines up and running. Probably a lot of you discovered that all you really had to do is Google your error message or error messages, and it took you to a link that gave you a detailed set of instructions for fixing your problem. And I also sent links like that to a whole bunch of people. So hopefully everyone's able to run a virtual machine in one way or another. If you are on a M1 Mac, then you had extra challenges. Unfortunately, Apple has decided to make everyone's life more difficult when it comes to running virtual machines. Morning, RoboGenko. So anyway, if you're on an M1 Mac, then either you found it or you got it through me or a classmate that you will be running a system called UTM. So if you are on an M1 Mac, there are going to be some things that you may not be able to do or that won't match what we're doing here on the live stream. And we'll just kind of have to let that happen but by next week, I don't think that's going to happen anymore. So just be patient through those small frustrations now that you have a running virtual machine. And we'll be in a place very soon where it doesn't matter what you're running in terms of a virtual machine environment, you'll be able to do the work for the class. Okay, I'm actually going to go to the, so that we can sort of do happier things for the course of the lecture. But I'm going to go look at Piazza and just give you a quick reminder. So over here on the left are a whole bunch of people who didn't follow the instructions. Now, some of you discovered afterward that there were instructions to follow and you went and fixed it, so that's great. But please read and follow the instructions. So for the discussion every week, the first thing you will do per the instructions is to find the filter for that week. The filters are these links at the top. The instruction for last week said find the filter week_1, and then using that filter, go find the tell us a little about yourself discussion. So it gives you 2 pieces of information: what filter to use and where the group discussion is occurring. So for week 2, you will see that it says in the instructions, use the filter for week 2, find the Linux distributions to explore discussion, click, and jump in on our discussion and contribute to it. So it's perfectly fine to make your own post with your own questions off to the side and use whatever filter you want. But for the main discussion prompt every week, if you're sort of out there not following the instructions, then your contributions are not likely to be seen by very many people. And I would prefer that that doesn't happen. So just the instructions are always short. It's always 2 things. Well, 3. Go to Piazza, find the filter, find the discussion, and post in it. Do those things, and then we'll all be happy. So there's that. Okay, so that's the thing at the bottom. Piazza, post in the discussion, means post in the discussion where everybody else is posting. That way, your ideas, your questions can be seen, and you are more likely to see other people's contributions. Okay, so we are in week 2, and for a while, in fact, probably all semester, I'll just remind you that everything that you need to find can be found here on the course homepage. You can, of course, use other ways of getting at material, but the course homepage is always a place that if you're in doubt, just go there. It's likely to tell you what graded assignments are coming up. It's going to tell you how to get in touch with me if you need to do that. It's going to give you links to all of the content for the course. The yellow rows, kind of the highlighted rows here in the schedule, are big things like the midterms, the midterm exam, the final exam, and then the distribution project. The distribution project, our discussion this week is actually related to the distribution project. So last week's questions, I think I'm correct. You got a question about what is a distribution and what does that mean? So that's just a first step toward doing the distribution project, is that question of what is a distribution. And I'll talk a little bit more about that today and then frequently going forward. But your discussion this week is asking you to go out and do some research on some various distributions and then contribute to a discussion about what is a distribution, what distributions look interesting to us, that kind of stuff. A distribution, by the way, is a very simple way to say it. And this is not a good answer, but just so you have something to hang your hat on. A distribution is simply a packaging of the Linux operating system with some other tools. That's all it is. And because the Linux operating system is free and open source, that means anybody in the world who has an idea for how they might package that operating system with other tools is free to do that. And then they are free to offer that packaging, that distribution, for other people to use. So in this class, the first distribution we are using is called Xubuntu. That's what most of you have installed. If you downloaded my 6 gigabyte thing, that is Xubuntu. That is a distribution. That is the Linux operating system packaged with some other tools. And I'll talk about what those other tools look like here today. Okay, so we're on the home page. We will go look at week 2, and then I'll get into the virtual machine environment so we can play around a little bit. And it's going to be easier for me to do a lot of this discussion if we're looking at a Linux system, which is why I'm going to get in there pretty quick this morning. Hopefully this doesn't mess you up. Does that mess you up? No. Okay. So our goals for the week, we're going to get introduced to the most basics of package management. And I'll talk about the details a little bit when we do it. If you are not on the Xubuntu system, you would still be able to get most of the answers around CalSA, but you may not be able to actually have the fun of doing the CalSA thing for yourself. CalSA is a program, and we're going to install it on our machine, and we are going to run it because it's kind of cute and it's kind of fun. So it is available for every Linux, but sometimes it's not conveniently available for every Linux. So on Xubuntu, it will be conveniently available to you. If you're on a different system because your computing environment needed to be a different system, then the CalSA parts may not be as exciting for you. Sorry about that, but at least you can see it. Okay, we're going to talk about the shell. What is a shell? Specifically, what is the bash shell that we use in this class? I expect, the idea anyway, is that I assume that none of you have ever heard of a shell. None of you have ever used a shell. None of you have ever heard of or used bash. Many of you have, so that's great. But the discussion will be assuming that you haven't before, and really being a confident user, a user who is able to operate a computer without a mouse. That's one of the big goals of the course. You shouldn't need a mouse to operate a Linux system particularly, but really you don't need a mouse to do most work in most computing systems if you know what you're doing. A mouse makes life easier and more convenient sometimes, but one of our goals in this course is to show you and then have you develop the skills that you don't necessarily need a mouse to do work inside of a computing system. And then the last thing we'll do is we'll explore some basic commands, some of the basic ways that we actually do perform tasks inside of a computing environment without a mouse. Okay, so there are some readings. Some weeks there's a few more. Some weeks there's a few less. Um, Hopefully everyone found that it was relatively easy to find the answers you were looking for. And then maybe if you took the time to read the entire readings, that you found some things that were new to you or that were interesting to you, at least some of the time. So our readings this week include something about the bash shell, some introductory material about Linux. We're going to encounter the sudo command. That one's going to be a little bit weird for people at first. Although most of you have experienced sudo, you just may not have known you were experiencing it at the time. And then the Piazza discussion will lean on this additional reading about Linux distributions. And as always, once the live stream's over, then I will do my best to get it uploaded and linked in everywhere before the end of the day. So just as a note, I have another live stream at 10. So I do my best to kind of rush and get everything posted up there. But if you go back later in the day and you find that the videos aren't there, please give me roughly 24 hours just in case. So the videos should be available no later than the time you wake up on Tuesday morning. Just because you never know, something could happen on my end, but I do rush to get all the videos linked to the various places as quickly as possible. If you want to view the video faster than I can get it posted, Twitch will have the video immediately at the end of the live stream. So if you are, if you have a link to my Twitch channel, then you can always get to the video immediately at the end of the live stream before I've linked anything. Okay, the lab this week. Okay, I didn't do any hands-on stuff. Well, we'll do that during the live stream. I clicked that, it didn't go anywhere. So the discussion, so this week it asks you to do a reading before you jump in on the discussion to learn a little bit more about the idea of a Linux distribution and 10 specific different Linux distributions that are popular with different users out there in the world. So the reading is there as preparation for doing the discussion, and then we'll give you material to throw in to the discussion. And then the typical instructions for Piazza. So log into your account, use the week 2 filter, find the specific discussion page, and then go in there and make your contribution. And then, so pretty straightforward week this week. Lab as always, discussion as always. So with that, let's switch over and do some of the fun stuff. So let me change your view so you can see my virtual machine. All right, so this is Xubuntu. What order did I say I'm going to do things in? Okay, we're going to do bash and a shell. Okay, so this is Xubuntu. Some of you, if you're running UTM, you may see something slightly different, but you're going to go to the same place as I go here, whatever virtual machine you're running, which is you want to find a terminal. So a terminal is a program that presents a shell to us, as it turns out. So I'm going to go and I am going to find a terminal. In this case, it's labeled as a terminal emulator. Some systems will simply call it terminal. Some systems will call it console. But they're all talking about the same thing. It's a window that has a text environment inside of it. So I'm going to click on that, or not. There, I clicked on it. So this window, more or less, is the terminal. And what it's doing me is it's giving me a way to issue commands on a command line. So I'm going to go through all the details. I know a lot of you already know all this stuff, but remember, there's a lot of us who don't. So this window is my terminal, and what the terminal is doing is it's presenting a text-based interface to me. So let's put, I'm not going to add additional notes. I'm just going to say words to you. So this is a command line interface, this terminal. The command line is the place where I type commands. That's the command line. So the idea of this text-based environment that the terminal is presenting to me is that I type commands in text, and then I see the results of my commands in text. So here's a really simple one as an example. One of the commands in here is date. So I'm typing the command date on the command line. So the command is date. I have typed it onto the command line. The command line is being shown to me through this terminal. And when I press enter, the results of that command will be printed in the terminal for me to view. So there's the results of the date command, which it turns out shows me the day of the week, the month, the date, the time zone, and then the year. So that's all of the stuff I got from the date command. And if I run it again, I'll see that the seconds have moved. So now I'm at 8:17 a.m. as opposed to 8:16 a.m. with 40 seconds on top. So what I am doing right now is I am interacting with this computer system on the command line. So that's a lot of words. And of course, they're all things that can be looked up and that you'll see questions on in the lab. So I am typing commands, commands, commands. I press enter when my command is ready, and then the result of the command is presented to me on the screen. So this is all text, right? The command is text, the result is text. There's no pictures, there's no icons, there's nothing that I'm clicking on. I'll move my mouse pointer around, but I don't need it because I am interacting with my system through a command line or text-based interface. Okay, so there's that. So now we have to add a layer on top of that, which is the shell. So what do we mean when we say a shell? A simple way, just for starters, is to think of the shell as the command line interface. So I am using a shell right now. It's hard to see. It's just text. But I'm using a program called the shell. And what the shell does is it accepts my commands, it sends them to the operating system, and then it returns the results to me. So I'm typing a command on the command line. When I press enter, what actually happens is the shell program takes my command, has it executed by the operating system, and then returns the results to me. Now that happens so fast that you can't tell that there's that extra layer, but that is what happened. I type a command, the shell program takes that command, has it executed, receives the results, and then displays them for me on the screen. So a shell is a command line interface to the computer. So just sort of adding an extra layer of terminology there. That's a lot of stuff. Okay, so a shell is a command line interface, which means that I can use the shell to interact with the system. I can issue commands to the system, and I can see those results displayed for me. So I'm going to type another command, clear, which in this case is actually just, so this does not need to be executed by the operating system. The shell will actually take this command and realize, oh, that's something that I do, not the operating system. So the shell will actually clear the screen. more or less, that I'm looking at. So I didn't need information from the system itself. I just needed my user interface, my shell or command line interface to clear itself so I don't have as much stuff to look at. Okay, so there's that. So I say shell, that's a generic term, and you have readings about this. So shell is a generic term that is referring to any piece of software that provides me with a text-based command line interface. There are many shells. The shell we use is called bash, B-A-S-H. Bash stands for Born Again shell. Not born, but born again shell. That's where bash comes from. B-A-S-H. That's the name of the particular command line interface software that we are running on our Linux systems. Hopefully, by the way, if you're in UTM, this is true for you also. If you find that you're not running the bash shell, let me know so that we can switch you so that you are. Okay, so that's the specific shell program that we are running right now on our Xubuntu systems, is called the Born Again shell, B-A-S-H. You can actually ask the shell to tell you about itself. So if I do echo space $ shell, I think, it will actually tell me what shell it is I'm presently running, which for me is bash. Don't worry about the bin part and the slashes part just yet. The shell I am running is bash. And it turns out that I can actually run other shells from within other shells. So if I want to, I can switch to the way old school shell just called sh. So one thing you'll immediately notice is that what I'm shown on the screen in terms of what I type next to is just now a $ as opposed to Butte at Butte VirtualBox. And if I echo shell now, hey, it's still showing me bash, even though it should be showing never mind. I've ruined my whole presentation. Let me do it this way. Oh, I know why. Okay, so that's okay. I'm still going to do this. And just kind of leave it as, you'll notice that instead of the extra information in green, I just have a $. So I'm actually running a different shell whose name is simply sh, not bash, just sh. This is called the Born shell. And this is sort of the original Unix/Linux shell, is the Born shell. It goes back decades. So it's one of the original command line text-based interfaces to a computer. So when someone came along decades later and created a sort of new and improved Born shell, they thought it would be cute, I think, to call it the Born Again shell, just to suggest that it had improvements added in. So we use the newer and improved Born Again shell as opposed to the sort of old school, one of the original shells called the Born shell. So remember, a shell is just a program that we type commands into, and then it has them executed and presents the results to us. That's all it does. The shell sits there, waits for us to enter a command. When we type in a command and press enter, the shell takes it, executes it, shows us results if there are any to be shown. And there are different shells, was the point. If you are running a shell and you don't want to be in that shell anymore, you can exit that shell. Now, when I exit this shell, it turns out that it just takes me back to the other shell that I was in originally. Some of this is going to be, but oops. I'll just show you I made a mistake. So I meant to type clear, but I accidentally typed CLAER. So one of the things that the shell just did is um, it realized that I typed a non-existent command, but the shell is actually trying to help me figure out what it is that maybe I meant to do instead. So the shell is saying, hey, maybe you meant clear instead of clear, whatever that is. The shell is also saying, hey, maybe that is something that you could install, since the shell doesn't know what it is. It's not. I just had a typo. So it's fine to type in something wrong. And if you're lucky, the shell, your text-based command line interface, may tell you, hey, I don't know what that is, but maybe you meant this other thing instead. So let me type it correctly. Press enter, the shell will cause it to be executed, which in this case is simply a wiping of the screen. All right, we're getting lots and lots of words, aren't we? Which I need to start being a little bit careful about, probably. Sorry, I need to do a little arrangement on the screen here. Okay, so that's a shell. It takes a command, it executes it, shows you the result, and it's all in text. So the second thing I have under bash is, what are other interactive shells? Now, what do we mean by an interactive shell? We simply mean a shell that interacts with you. You give it a command, it gives you a result. That's an interaction. So that's what we mean by an interactive shell, is it receives commands, it presents results. It interacts with us and allows us to interact with it. Okay, so that's the basic of shells. We are going to use the born again shell, which is kind of a new and improved. Some people would consider the born again shell, or bash, to be sort of one of the older ones now. There are a whole bunch of different shells. There's the original born shell. There is the corn shell. There's the public domain corn shell. There's the TC shell. It's common on Mac. There's the C shell. There's fish, which is a shell. There is the Z shell, which is the one that I use on my computer. And what do we mean when we say all those different shells? Those are all programs that allow us to interact with the computer by typing commands and viewing their results. They all offer slightly different sets of features. Just like if you've ever used a Mac versus using a Windows, their graphical user interfaces have slightly different features and arrangements to them. But still, they're effectively, the purpose of them is the same, which is to allow you to perform tasks on the computer. So that's what a shell does as well. It lets us perform tasks on the computer. There are many different versions of them. The one version we will use in this class is the born again shell, and we will learn it kind of inside and out. It's a very popular shell. Possibly the most popular, if I had to guess. But I don't have the numbers. Okay, so that's the basic feature of a shell. Lets us type in a command and view the result or results if there are any. Shells have other features in them. They are actually an interactive programming environment, and we're not going to get into programming much in this class, but it turns out that the shell is somewhat programmable, meaning you can do a variety of things to customize the shell and have it perform tasks in a custom way for you. I'm not going to do anything super fancy, but I'll just show you one example. I will say, let's do this. Let's put a thing in a shell. So I'm going to say fruit equals, and no spaces here. So fruit equals banana. And I recommend that if you're following along, you type it exactly like I do, so it'll work. One thing that's true about the shells in Linux is that they are case sensitive. So capital letters and lowercase letters are not interchangeable. If it's capital, it has to be capital. If it's lower, it has to be lower. So watch out for that kind of thing. So fruit equals banana. So what I have done is I have stored a piece of information inside of the shell environment called fruit that has the value associated with it called banana, and I can actually then recall that information from the shell. So the shell is a programming environment. Essentially, we can actually store information in it, and then we can access that information and operate on it if we want. I can also do something fancier, by the way. I can say, I would like and I can actually have the shell kind of play, what's that game? Mad Libs, where you fill in the blanks and then you get sort of crazy sentences. And I don't want to overwhelm you with programming stuff. Later in the semester, we'll do a little bit of using the programming tools that are built into the shell. So what I'm telling you, though, is that the shell is not just a place to type commands and see results. It's also a place where you can do programming in it. So it acts as sort of a programming environment where you can create data. You can manipulate that data like a programmer would. You can automate tasks that you would like to perform. And by automate, I mean simply that you can sort of put together a collection of commands, and then you can have the shell execute the entire collection of commands for you in one fell swoop, which is kind of a neat feature to have. Yeah. Okay. So this question. Okay. So the $ next to fruit. That's a good question. So why do I do the $ next to fruit? So without the $, what I'm telling the shell is I want you to store this piece of information with this label on it. So I want to use the label fruit, and the information I want to associate with that label is cherries now. And then when I want to recall the information, I can say, I want to recall the information that's attached to that label. So the $ tells the shell, I want to know what information is being stored that's associated with that label. And then the shell will tell you, oh, what's associated with the label fruit is the value cherries. Because if I just say echo fruit, then the shell just thinks I want to see fruit on the screen, and it doesn't know that it's actually supposed to go look up a label and find a value associated with it. Oh, by the way, if you were to exit the shell, so I'm going to type exit here. If you are to exit the shell, that also causes the terminal that it was being displayed, that was running inside of, to shut down. So if I were to come back and reopen the shell and try to get that value fruit back, it's gone. Now there are ways to make the data survive, but if you shut down the shell, sometimes some of the information that you've been storing up inside of there will be lost unless you save it somewhere. So the shell is perfectly happy to see if it can find a value associated with fruit now that I've shut down and restarted the terminal with the shell in it. But it finds nothing, so it just prints nothing. Okay. The shell can do math, but math looks a little bit weird, so I'm going to wait on that. I'm just telling you as a feature that the shell can perform basic arithmetic operations. I also wrote down alias. So there are a variety of ways that you can customize the shell, and I'll just give you an example. So I can say, so you guys probably remember that I mistyped CLAER, and I got an error. But let's just say, for argument's sake, that I do that frequently, and I do it, in fact, so frequently that it starts to get in the way of me being productive. One feature of the bash shell is that I can alias things. So I can say, you know what, just make CLAER be an alias for CLEAR. And what this means now is that the shell will interpret CLAER to be the same as CLEAR, which means that either of those would clear the screen. So I'm going to hit enter, and then I'm going to type CLAER, at which point the shell will say, oh yeah, that's an alias for clearing. Or if I liked it, I could say something like, you know what, I'm going to shorten that even more and just say CLR means clear. And then I can type CLR and that will clear. Now, aliases is another thing that disappears unless you know how to make it stick. So we won't worry about that just yet. But another feature of the bash shell, which many shells have but not all, is this aliasing feature where we can create aliases or alternative spellings or alternative ways, shortcuts, if you will, for executing different commands. So right now I have the alias CLAER clears the screen. I have CLR clears the screen, and that's both using aliases for the actual clear command. So that's another feature of the bash shell, is this idea of creating these aliases. And there are many features in bash, and we'll come back and sort of do more customizations on bash at a future date. The last, just sort of what I saw come up in the readings a little bit. So you see the term script there, or scripts. So a script is really just a text file that contains commands in it. Now, most of us, when we talk about scripts in Linux, we mean something that is a little bit like a small program for the shell to execute. So you can think of a script as a way to capture a shell program in a file. And the nice thing about scripts is that you can save them, and then you can execute the script, and then you sort of always have whatever the commands you put together in your script that can be performed for you. And we'll do some scripting later in the semester. So the bash shell, not only is it a live programming environment, but you can actually save scripts, which are small programs basically, and execute them over and over and over and over again if you want to, like any other program basically. Okay, so there are those things. What else? Okay, next section, some basic commands. So you've seen the clear command. Another way to, let me just put some stuff on the screen. I am in the habit of always typing clear when I want to clear the screen, but the bash shell also supports the Control L, which you can see in my notes there on the lower right. So hold down Control and press L is a shortcut for clearing the screen, but I don't find myself using that for some reason, even though I know it's there. Okay, and then a couple of other basic commands. I should have put them in a slightly different order. You've seen me type exit, and exit, when I'm running in a terminal, what exit's going to do is cause the terminal to exit and close down the shell that was running inside of it. In a week or two, we will see that exit also has a different use depending on how we're logged into the system. But for now, if we're running this graphical desktop, we have opened a terminal and we type exit in it, it causes the terminal to shut down, which I don't really want because I want to do stuff in the terminal. So I have the terminal, and the terminal is giving me access to the shell, and the shell allows me to type in commands and see their results. All right, so that's where we're at. The shell can do a lot more than just that. We just got a brief introduction to the idea that the shell is not only a place to type in commands and see their output, but it's a place where you can actually do some simple programming. It has some customization features like creating aliases that allow you to give yourself shortcuts for commands. You can create scripts, which are basically shell programs written in the shell's own programming language, and a variety of other customizations that we'll see in some number of weeks. Okay, so I have the terminal running, which means I now have the shell in front of me, which means I can type commands. So let's do a couple of the very fundamental commands. One of them is ls. So ls is a listing, and what it will list is the contents of the directory that you're in. Now this is going to be confusing for some of you at first. What directory am I in? We're going to go figure that out, and then we're going to use the shell to figure it out. So this ls command is listing for me the contents of my directory that I am looking at through the shell. And the contents of that directory are desktop documents, downloads, music, pictures, public, templates, and videos. I'm going to go figure out what directory this is the hard way, and then I'll do it the easy way. So the hard way is to use the graphical environment. So I picked up my mouse. I'm going to use the graphical environment for a moment to figure out which folder this is that lists these contents. So, well, I have a folder here called home, so I'm going to double click that with my mouse. Aha, this is it. This is the same directory. Do you see it's got desktop, documents, downloads, music, pictures, public, templates, videos. So my terminal, and thus my shell, are actually kind of viewing this folder. You see, it's the same contents. So I'm viewing my home folder here in the graphical environment and here in the text environment. It's the same place with the same contents in it. One of them is graphical. That's the one with the folder pictures. The other is text-based, which is what the shell is showing me. So I'm going to close the graphical one, and let's use the command line to do the same kind of work. So I listed the contents. Now in the graphical environment, I could see that it was my home folder because it's labeled. In the shell, you can see what directory you are looking at by typing pwd. That stands for present working directory. Present working directory, which is simply what folder am I looking at when I'm here in my shell. But the command for it is simply pwd. It's /home/Butte. Don't worry about the slashes and all that stuff, but I'm going to bring the graphical environment up one more time just to show you that, in fact, they are the same thing. So see up here at the top, /home/Butte up here. Can I highlight it? I can't. So that is a view graphically of that folder, and here is a view in text of that same folder. And one of our goals, in fact, like the big goal, in my opinion, in this class is to make it so that you are very comfortable operating your system just from this text interface, from the shell, such that you don't even need a graphical environment if you don't have one. It wouldn't matter. And for a while this semester, we're going to get rid of the graphical environment and work entirely in text, just so you've had that experience and you realize, oh yeah, I didn't even need the graphics for much of the work that I do. Of course, if you want to watch movies and stuff, then you probably need the graphics. But for lots of the basic operations, you don't need graphics. Okay, so there's two commands that we've used. The ls command, which is a listing command, it lists the contents of the present working directory. How do I know what the present working directory is? It's pwd. Present working directory is simply what folder am I in right now, so that when I do a listing, what folder's contents will I see? We're going to move around a little bit. In fact, let me just add it to the notes so that you have it there for reference. We're also going to do the cd command. Are we? Maybe that's too much. Yeah, I think that's a bad idea. That's too much. Never mind. Okay, so we have these two commands. There's one other command in here that I want to start getting you familiar with right off the bat, which is the manual system. And by manual, I mean the user guides that are built into the system that you can access with our shell. So to access the manual system, you type the command man, which stands for manual, which means they want to see a user manual for something. And then you tell it what you want to see the manual for. So I want to see the manual page for this ls command. So man space ls, it will bring me the manual page that describes what this ls command is all about. So I'm going to press enter. There's a lot of stuff in here, and we're just going to worry about the most basics to start. But now I'm in a manual page. It is about the ls command. I hate the way this highlights, but if you go here to the top, you can see name, ls, list directory contents. And then there's some kind of synopsis section that says option ... file ... We're going to learn how to read and use that information. But we might just read the first bit of the description. List information about the files, the current directory by default, and sort entries alphabetically. Okay, so this is a manual page for the ls command. And you'll notice at the bottom it says you can press Q when you're ready to quit. You can actually scroll down through the manual page with the up and down arrow keys. So I'm going to press the down arrow and just show you that there's a whole bunch of more information in here. It's actually shocking how much information there is about a command that seems so simple. Like, aren't I just listing the contents of a folder? Yes, but it turns out that there's a whole bunch of different ways you can customize the results. Kind of like filters, if you want to think of them that way. I can filter the results. So anyway, I'm arrowing down and then I'm arrowing back up so that I can kind of look through the manual page for the ls command. And when I'm done, I can press Q on the keyboard. And now I'm back to my command line, back to the shell. By the way, if you want to see the manual page for the manual system, you can do that. The manual system has a manual page for itself, which is awesome. So here it is, an interface to the system reference manuals. And then you'll see if you arrow up and down, it also has a lot of information to give you more details. So man is the system's manual pager. Each page argument, anyway, you get the idea. And Q when you're ready to quit. Let's see if PWD has a manual page. And this is to point out to you that not every command necessarily has a manual page. Let's see if this one does. It does, so that's good. Some commands, though, when you go to try to bring up a manual page, they may not have one, and that's fine. They're just not all of them have them. But most of them do that we will use. So PWD, here's the manual page for PWD. Print the name of the current or working directory. And then notice it also has sort of additional options that you could use. Up and down arrows to sort of see the extra information, and then ultimately a Q to quit and bring myself back from the back to the command line. I'm going to try one on clear. That's a command we've been using. It has one, so that's pretty awesome. Clear the terminal screen. Easy enough. Clears your screen if this is possible. Turns out that it even has additional information associated with it. Okay, so there's man pages on, does exit have a man page? It does. Cause normal process termination. So sometimes the man page might not read very understandably to me. That's okay. It's worth kind of experimenting and see which commands have man pages and see if there's any information in there I can make use of. But get used to this idea of, well, someone told me about a command. Is there a manual page? And can I begin to read and understand what the manual pages are trying to tell me? We will spend a lot of time in manual pages learning what the meaning of all that extra stuff is. Okay. There's all that stuff. So I'm running a terminal. inside the terminal is running a shell, which is a text-based or a command line interface. I'm going to clear. Most of the time you'll see, I think, people spell command line like this. Sometimes they'll spell it all as one word. Sometimes they'll put a space in between it. But that's what I'm talking about. And a command line is simply the line on the screen where you can type in a command, right? Like date. Oh, I should have put, I should have put one more thing in here, and I'm going to go put it and talk about it and then do the last thing. Last thing, will it fit and not push things off? It will. So the last thing I want to add to this is the concept of the shell prompt. Okay. So I just added shell prompt to the screen here so that I can talk about it. The shell prompt is simply the place where the shell is waiting for you to type in a command. So this line right here where there's the square, the white square, next to this $sign and the squiggle and the other stuff, that's the prompt or the shell prompt. That simply is referring to the location on the screen where you are expected to type your commands. So the shell is kind of telling me here, hey, I'm ready for you when you're ready to enter a command. Or in other words, the shell is prompting me to give it a command. Hey, give me a command. I'm ready to do some work. So that's the shell prompt. Okay, now let's do a little bit, touch a little bit on package management. So I'm going to try the calce command here. Okay, and I get command calce is not found. So this is the shell, by the way, receiving this command calce space hello and realizing there's no such thing on the system, but turns out that you can have this thing on your system. For those of you not running Xubuntu, you may or may not see this. So for the purposes of the lab, you can just follow along this video and get the answers from the video. Or if you want to, you can go do a Google search for your virtual machine environment that you're running, and probably somewhere out there you will find instructions for how to install calce on your system. Okay, so we need to install a piece of software. So this will give us our first excuse to do what's called package management. Package management is just a fancy way of saying installing software on the machine. So I want to install the calce software. And package management is the general sort of class of operations that I would use to install this software. Package management, by the way, also means uninstalling software, and it can also mean updating software to newer versions. Just like you do on a Windows or a Mac, sometimes a program that you use gets a new version, and either you or something in your system will update it. That's package management. When you, on a Mac, if you drag an application to the trash, or on Windows, if you uninstall an application, that's package management. And on Windows and Mac, when you get a new piece of software and you install it on your system, that's package management. So that's what we're talking about when we say package management. But in the command line, there are specific commands to do package management. And we're going to use one today, which is the package manager in Xubuntu, and we're going to use it to install this calce program. And it even tells me up here how to do that. So the first thing I'm going to do, though, no, I'm not. I'm just going to tell you about it. So if you see the words up here, it says sudo space apt space install space calce. So what does all of that stuff mean? Sudo is a way to temporarily elevate your user privileges to be an administrator level user. So You've probably done this on a Mac. If you've ever clicked on one of the unlock icons on a Mac, you are actually performing a sudo type operation. You have to typically enter a password, and that gives you more privileges to do changes. And on a Windows machine, you may have done a run as administrator before, which will have required that you elevate your privileges, meaning give yourself more power on the system to do things like install or remove software. So in our command line environment, sudo is a way for us to temporarily get administrator rights so that we can install software. APT is the package management system software in Xubuntu. So APT is the package manager, and I can't run that without the administrator privileges that sudo give me. So I'm going to use sudo to get privileges to run APT, the package manager. The specific type of package management I'm doing is installing software, so install. And then the specific software I want to install is called Calce. So I'm going to sudo elevated privileges, APT, the package manager. Which specific package management operation do I want? I want to install a piece of software. And finally, which specific piece of software do I want to install? Calce. I'm going to press enter. It's going to ask me for my password, which you've probably done this on a Mac, and there's a good chance you've done this same kind of thing on Windows, where if you want to be have administrator privileges so that you can unlock system settings or install or remove software, you have to do this thing. Our password is STUDENT. You'll notice that the cursor on the screen didn't move, so it was silently accepting my password. That's a security thing. So people can't, in theory, count the number of characters and then try to guess your password. So I very carefully just typed in STUDENT, and I'm going to press enter, and then stuff's going to happen. So all of that stuff on the screen is actually the shell reporting to me the results of the command. So I elevated my privileges. I ran the package management software APT. I chose the install operation, and I chose the specific piece of software I wanted, which was Calce. The shell took that long command now with multiple components on it, executed it, and then reported the results back to me. So read package list, build dependency tree, whatever, we'll get to that. Reading state information, I'm not too worried about that. I am excited, though, by the fact that it says the following new packages will be installed, Calce. So 0 upgraded, so it didn't do any software upgrades. It did one new installation, and then apparently there might be 7 pieces of software somewhere in my system that could use an update. It tells me how much disk space was used. It gives me some version information, and then kind of lays out the process that it used to install the actual software. So now Calce is installed. I'm going to clear, and I'm going to try to run that same command that I ran before. There's Calce, one of my favorite little utilities in Linux. So it turns out that what Calce does is it takes your little message like hello and has a Calce in text, right? So Calce, I'm going to try more words. So I'm going to say hello, Boyd. And I'm going to put more than one word inside of quotes like this. So now the cow is saying hello, Boyd. Let's use the man page and see if there's more that we can do with Calce. So I'm going to clear, and then I'm going to bring up the man page for Calce. Hopefully there is one. There is. What? There's a cal think? Well, I haven't tried the cal think. So Calce generates an ASCII. This term ASCII, by the way, that just means text. Calce generates a text picture of a cow saying something provided by the user, like I just proved. And I'm going to scroll down, and we're just going to see our first option. Did it show it? It didn't. Okay, but I'll show you where I'm finding it because I know it's there. Right here in the center of my screen, it says the -F option specifies a particular cal picture file to use. So we're going to have fun with that in a second. And if we scroll down a little bit more, and most of this is because I know where to look for this. So -F, we'll keep that in our head. And it says a particular cal picture file to use. If I keep going down to this environment section, I will notice this folder called user share calc cals. So I'm about to type a longer command, /use user usr /share /calc /cals. I'm about to use that information in combination with -F to have just one more bit of fun before we close down. So I'm going to Q to quit the man page. So I'm going to type a longer command, /user /share calc /cals. So that's ls because I want to do a listing, but I want to do a listing of a particular folder. The folder is /usr /share /calc /cals. So this is going to give me a listing of all the calc pictures that are available. Not all of these. Some of these are a little bit off color in my opinion. So these aren't necessarily things that you should be experimenting with anybody over your shoulder at work, or possibly with children around. Just not all of them are. Some of them are adult and not pornographic necessarily, but just be careful of that because some of these pictures are just not the nicest kinds of things in my opinion. So anyway, just keep that in mind. So these are all the cal pictures we can use. So we can do this. I'm going to do a pony. No, not a pony. Let's do, I don't know. I'll do a duck. So I'm going to do calc. And then the manual page space told me if I use this -F filter, I can specify a different picture. So I'm going to say use the duck file, so the file duck, to say hello Boyd. So there's a duck saying hello Boyd. Why can't I grab this? I'm trying to grab it and stretch it around, but it won't let me get it. Had it. You thing. I can grab the top one. I wanted to stretch out the screen so you can kind of see everything that I just did. So I went and looked at the man page. I figured out some stuff about calc, which included that you can use different pictures instead of just the cal. So I used a listing on the picture folder, which is what the ls user share calc cals command was about. So I got myself a list of all the cal pictures available, and then I ran the calc command with the duck file or the duck picture. Let's see, cheese. I'll try cheese, and then that will be it. So I'm going to say calc-f cheese. Have a great day. So the cheese picture is quite a bit larger. So for those of you who are on Xubuntu, hopefully you find that a little fun for a few minutes like I do. But the point is to get you sort of to begin to get comfortable with doing text-based commands and reading text-based output through your shell using the manual system. And then also we did a quick sort of exploration of one simple use of a package manager, which was to install calc on our Xubuntu systems. Okay, that's gone over by a few minutes. That's where I need to stop. So it was great to see. Actually, who can I see? And I'll say, have a great day to you. So a hex thing, I think. OAX 420 Academy, Alexis Alien Conglomeration, Alien Gathering, Anna Banana, Casino Commander, Farming Girl, Gels, K, Robogenko, Rogue, Roxy, Sophia, that one kid, and Violet. Nice to see you all here. Those are the names I can see in my streaming software. So if you're here and I can't see you, I was glad to have you here in the stream. I hope you have a great week. I think we're all past the pain of getting the virtual machine running, but if not, we'll keep communicating and we'll work that out. Thanks for a great first week. I appreciate that everyone was able to get in and do all the things. So that makes me feel good because I hate to see people not do things or fall behind. It's stressful for me, like it no doubt is for you as well. Because it's a lot more fun just to know that everyone's going along and everyone's hopefully learning some things and having fun where the fun can be had. So have a great day, everybody. There's my little cheese picture. We'll see if the Twitch algorithm finds my little cheese picture as the screenshot for this. So I will see you, if not sooner, next week. Don't forget office hours by Confer Zoom or the drop-in time from 4 to 5 on Thursdays are there for the rest of the semester. So have a great week. Keep up the good work, and I will see you on Monday next week.